Hello, this is lesson 4.6, square and cube roots, and you should have this handout already in front of you before you start these notes. And if you were absent, you can find this handout on my website, and it's two-sided. On the other side, you're going to see square roots, the word square roots on the back side of this section, and then the words cube roots on the back side of this section. And later, if I have time, I'll show you what it should look like once it's folded up. So anyway, what we're going to do first is focus on the left side, which is the perfect squares and the square roots examples. Okay, so let's first take a look at the perfect squares table on the far left of the handout. And these symbols that you see in the table is what we call radical signs, or as some people call them, square root symbols. I'm going to use the word radical sign in this video. And we're going to write the perfect squares in this column here. So to get the perfect square, we take this number on the right column and we square it. So 1 to the second power is 1. That's our first perfect square. And then to read that, we say radical 1 equals 1. 2 to the second power is 4. So radical 4 equals 2. 3 to the second power is 9. Radical 9 equals 3. So you're going to continue with that pattern. 4 to the second power, 5 to the second power, etc., until you're done. Now, I would think that you could do all the way to 12 to the second power, which I've already started filling out at the bottom, as you can see. Okay, so I'm going to let you see that in just a second. So we're going to write the rest down. Okay, and now I'm going to zoom out so you can see the rest of the table. So these are all the perfect squares, and you can pause the video to copy it down. But what I would expect for you to have memorized is the first 15 perfect squares, all the way to 225, because those are most commonly used. And if you memorize them, then when you solve problems with perfect squares, it'll be a lot quicker and easier. So pause the video to copy it down, and then when you're ready to continue, press play. Please pause now. Okay, let's take a look at the squared examples. Example number 1 says, evaluate without a calculator. For 1a, it says radical 49. So you would use the square root table, and you would see that radical 49 equals 7. And then you would just write equals 7 without any square root symbol or radical sign around it. Now for 1b, we have negative radical 16. So you would do the radical 16 first, and that would be 4, and then you put the negative in front of it, so then your answer is going to be negative 4. Now for 1c, it says positive or negative radical 100. So always do the radical first. Radical 100 is 10, and then you put the positive or negative sign in front of it. So then positive or negative 10 is your answer. Now for 1D, it says radical negative 49. So a lot of kids will say, well, I think it's negative 7, but negative 7 times itself, negative 7, is positive 49. So it's not negative 7. Instead, we will write no real solution, because there is no number times itself that's going to give the answer negative 49. Let's take a look at example 2. So for problem 2, says estimate without a calculator, round to the nearest whole number. So to estimate these radical signs, radical 60, you'll notice that it's not on our table. So how do we find it if it's not a perfect square? We look at the two numbers that 60 falls in between, which is 49 and 64. So the way I want you to show your work is I want you to draw these branches going out like this. And then you're going to write the two radicals that it falls in between. So like I said, it was radical 49 and 64. And then ignore the radical signs and just look at the numbers itself, 60, 64, and 49. Well, 60 is closer to 64 on the number line. It's only 4 units away, versus to 49, it's 11 units away. So we circle this one here, okay, because it's closer. And then that means that radical 60 is about 8. and that's my about symbol. My wavy equal sign means about. Okay, so then for 2b, it says the negative of radical 23. So we're going to go ahead and again and look at this chart here. 23 itself, without the negative sign, is in between 16 and 25. Okay, so 16 and 25, except they're negatives. So what we're going to do is we're going to put negative radical 25 on the left and then negative radical 16 on the right. And I would just say ignore the radical signs for now and look at just the number inside the symbol. And 23 is closer to to 25. So then I'm going to circle that in red. And that means negative radical 23 is about negative 5. Okay, now let's take a look at number 3. The number of miles a person can see to the horizon, where h is the person's distance from the ground in feet, is d equals 122 times radical h. The observation deck of a building is 370 feet high. How far to the horizon can a person see on the deck? Round to the nearest tenth. So we're going to use this equation right here, and we know that 370 feet is the distance from the ground to the observation deck. So that is what h is. So then we just plug it into our formula. So here is our equation. And the problem with this is it wants us to round, it says to round to the nearest tenth. We could estimate to the nearest whole number. Radical 370 is going to be about 19. But to round to the nearest tenth, I would let you use a calculator. So if you put that in the calculator, radical 370, you're going to get 19.2 to the nearest tenth. So let's go ahead and write that in there, 19.2. And now we multiply it to the 122. So then our answer is 2,346.7, and we label it feet. That is how far the person would be able to see to the horizon from that observation deck. Okay, now let's take a look at the other side of our notes, the perfect cubes. And on the perfect cubes, notice that it still has what looks like the radical sign here, but has a little 3. So this is the cube root symbol. So to get the perfect cubes, what you do is you take that number 1 and you cube it. So 1 to the third power is 1. And then you do the next one. 2 to the third power is 8. 3 to the third power is 3 times 3 times 3, which is 27, etc. Okay, so we would say the cube root of 1 equals 1, the cube root of 8 equals 2, the cube root of 27 equals 3, etc. So I'm going to have you fill out the rest right now. I don't expect you to memorize as much as I do the perfect squares. But I would say to have at least, the first 7 or so memorized, okay? Only because they're common, and it's just easier to see, oh yeah, it's a perfect square, for perfect cube, excuse me. So anyway, here are the other perfect cubes, and pause the video if you need to, so you can copy all of them down. Let me try to zoom out so you can see them all at once. Here they are. And when you're ready to continue, press play. Please pause now. Okay. So let's take a look now at problem number 4 on the cube root examples. So very similar to a cube, the perfect squares or the square root examples. Evaluate without a calculator. So you could use a table for this. Radical 64 is equal, cube root of 64 is equal to 4. Okay, and then that would be your answer. Now for the cube roots, notice this one has a negative inside the cube root symbol. That is, you can actually do that. You can have that and have a real solution. 1331 is over here. 1331. Cube root of 1331 is 11. So when the negative's inside the cube root, it's going to be negative 11. And the reason why that is true is because if you think about it, if you do negative 11 times itself 3 times, you're going to have 3 negative signs. So those 3 negative signs is going to give you a negative answer. So that's why you can have a negative inside the cube root symbol. So then cube root of negative 729 is going to be negative 9. So write negative 9, and then cube root of 343 is going to equal 7. So for number 5, it works very similar to the problem 2, and where we have to find the 2 cube roots now that are in the between, that negative 20, 24, it falls in between. So that's going to be right here. So again, when you show your work on your assignments, you're going to write the 2 cube roots that fall in, that the number falls in between. Okay, so then this number is closer to this cube root, and so that means my answer is going to be about negative 13. Okay, and then on number 6, it says if the volume of the cube is 3,375 inches cubed, what is the side length? Okay, so on a cube, each dimension is the same. So all this, the length, width, and height is the same. So x to the 3rd power, okay, is going to give us the volume, and that's going to equal 3,375. So to figure out what that x is we take the cube root. So we write it like this. We do a little square root, but a little 3 on there. So the cube root of x to the 3rd power is x. And then the cube root of 3,375 is 15. And then we label it inches. And that's all for your notes. Thank you very much. Bye-bye. Oh, and there's no secret word, code word. Bye.